right, my friends, 14 part C is definitely a challenge. I hope you've toyed with it before you watch this video, just to kind of see if you could figure it out on your own. I think it would feel pretty good to figure it out. So I'm going to copy the original problem, and then the first challenge is factoring that denominator. And sadly, it does not factor by grouping. So you're left with the rational zeros theorem, or also known as the P over Q thingy. But funny story, I don't know if you've ever noticed, but positive and negative 1 are always in your P over Q list. And so what I'm going to do is just check in the denominator what happens if you plug 1 in. So 1 cubed is 1, minus 1 squared, plus 1 plus 3. If you add these together, we don't get 0, which means positive 1 is not a 0 of this polynomial. But look what happens if we plug in negative 1. Negative 1 cubed is negative 1, still be minus 1. It would be minus 1 here, and then plus 3. And so that was a quick way to check that negative 1 actually is a 0 of that polynomial. And if negative 1 is a 0, then x plus 1 must be a factor. So we've already got it partially factored. So x squared minus 4x plus 7 would be over x plus 1, and now it's just a matter of figuring out the rest. And that would be up to you and your favorite version of division. You can use polynomial long division or synthetic division. I'm going to use synthetic. So synthetic for x plus 1 is negative 1, the 0 that corresponds to the factor. And then synthetic for x cubed is 1, negative x squared, negative 1, positive x is 1, and then 3. Synthetic division here, we're going to drop the 1, multiply, we get negative 1, add, you get negative 2. Multiply, you get 2, add, you get 3. Multiply negative 3 and add, you get 0, which is what we should expect. So interpret the 1, negative 2, 3 as x squared minus 2x plus 3. And now we have it factored. Factoring x squared minus 4x plus 7. Let's see, are we going to be able to factor that using rational numbers or reals? Let's see, no. Okay, so that means we have to leave that a quadratic. That's why I put this on the assignment, because I wanted to make sure you had some practice with quadratic factors. So if you can't factor something, if you have to use rationals or imaginaries to factor something, then we're going to leave it a quadratic in this case. So it affects your form. So we're going to have a constant over x plus 1. And now, because we're going to leave that x squared minus 2x plus 3 as a quadratic, you would put a general linear above it. All right, my friends, now we're going to fight the denominator battle. So we need to add these together and get this denominator. So we'd have a over x plus 1. It would get multiplied by x squared minus 2x plus 3 over itself. We're going to have bx plus c over x squared minus 2x plus 3, and it would need to get multiplied by x plus 1 over itself. Okay, so now what are we going to have? I'm going to distribute, this in. We'll have ax squared minus 2ax plus 3a. I'm also going to have a good time distributing these guys together. So we'll have bx squared plus bx plus cx plus c. When you do that, and it will all be over, and when you multiply these two together, you will get x cubed minus x squared plus x plus 3. Okay, denominator battle 1. Numerator battle. So we need this expression to be equivalent to this expression, okay? So to accomplish that, I'm just going to copy x squared minus 4x plus 7, and then I'm going to group these by like terms, as in whether they're x squareds, x's, or non-x's. So we've got, let's see, ax squared and bx squared. So that would be like a plus b times x squared for those two terms. And then we've got negative 2ax plus bx plus cx. So that means we've got negative 2a plus b plus c times x. And then the remaining terms are our constants. Whoopsie, 3a plus c it looks like. Okay, so now system of equations, we need a plus b to equal 1. We need negative 2a plus b plus c to be negative 4. And then we need 3a plus c to equal 7. So that's your system of equations. Okay, how to solve this? When I've got one equation with more letters than the others, I do kind of switch to substitution. So row 1, I think I would isolate b, so I'll have something to put in here that's in terms of a, and then this one I'm going to solve for c, so I'll have something to put here in terms of a. So b is equal to 1 minus a, and then c is equal to 7 minus 3a, and then I'm going to substitute both of these expressions into row 2. So row 2 would then say negative 2a plus 1 minus a for the b there, and then plus 7 minus 3a for the c there, and then equals negative 4. Solving this, let's see, what do we have? Negative 6a it looks like, plus 8 equals negative 4. Subtract the 8. And then that means a would be 2. Once I know a, I could go here. If a is 2, b would be 1 minus 2 or negative 1. And then c, if a is a 2, we would end up with 7 minus 3 times 2, so c would end up being positive 1. All right, good time. So now we take these 3 values and then we back substitute them into your form, which was right there, and we can make our conclusions. So therefore, the mess known as x squared minus 4x plus 7 over x cubed minus x squared plus x plus 3 can be written as 2 over x plus 1 plus negative x plus 1 over x squared minus 2x plus 3. And there we go. We've taken one big mess and replaced it with another big mess that in Calc BC we'll actually be able to integrate where we wouldn't have been able to do that one. All right, my friends, I hope this helps. Take care, everybody.